So again, what I'm using here is a different method, right? You know, we have, as you can see, let me get back to the slides. We have, right? What we have is this. We have a trinomial, 3 terms, degree 2, leading coefficient 1. So we want two numbers whose product is -5, the constant term, and whose sum is 4, the coefficient of x. So we get -5 is this product. We get 4 is the sum. You know, we want to fill in the blanks, so to say. Well, hopefully it's easy to see. Well, especially since it's written right here, we have 5 and -1. Of the two numbers you use, the sign of the biggest one has to be plus. You know, 5 and 1, right? But 5 has to be positive, 1 has to be negative. You know, that's what this is telling us. I mean, I hope that made sense. I mean, if it didn't, that's okay. But again, basically what we have is two numbers, right? We want whose product is -5, whose sum is 4. And 5 and -1 pull that off. If you multiply them, you get -5. If you add them, you get 4. So we get this polynomial is this product. And altogether, the original polynomial is equal to this product. So that's what we get. Sure. Good. Are there any questions about this? I really hope that made sense. Okay. Well, let's do another one then. Not synthetic division, but this one deals with quadratic functions. Here, right? Here, we want to find a quadratic function, excuse me, whose vertex is 1, 4, and it passes through the point 2, 6. So the graph passes through the point 2, 6. Well, since we know what the vertex is, it probably wouldn't be smart to use this form, the vertex form. I mean, you could use ax squared plus bx plus c. I think they call it the standard form. But, you know, this is a lot easier. Because hk, right, that point is the vertex. So we get h is 1. We get k is 4. So again, the hk, that's the vertex, right? That's equal to this point, 1, 4. And if 2 points are equal, corresponding coordinates are the same, meaning their x coordinates are the same. So h equals 1 and k equals 4. So h is 1, k is 4. Okay, so we have this so far then. Okay, so again, that's what we get, right? So the points are the same. That tells us the x coordinates are the same, h equals 1, and the y coordinates, k equal 4, are the same. But notice we're not quite done yet, right? We don't know what a is. That's okay though, right? Because what else do we know? We know the graph passes through this point. So if it passes through this point, that means f of 2 must be 6. So f of 2 must be 6. That's what we know. That's what we know. Okay, so let's use that. So we have when x is 2, the function must equal 6, right? That's what I just said. So we get 6 then is a times 2 minus 1, right? I'm replacing x by 2. F of x, I'm replacing by 6. And now we can solve for a. We get 6 is a times 2 minus 1 squared plus 4. And we want to figure out what a is. So a times 1 squared plus 4. A times 1 squared plus 4, right? Well, 1 squared is 1, so we get a plus 4. So we have 6 equals a plus 4. We just solve for a. No problem. No problem. We just isolate a, right? So we subtract 4, we get 2 equals a, and so a equals 2. Theoretically, we could stop at this line here, because we know what a is. It's really better to have the unknown on the left-hand side. That's just a convention that mathematicians take. But either way, we get a is 2, and so we get f of x must look like this. I mean, you could graph in Desmos to see if your answer is right. That is this point on the parabola, and is the point 1, 4 really the vertex? And you should get that it is. You could graph it in Desmos if you want, as a check. All right. Any questions on that? Someone actually asked in my other class, can you use the slope of a line, that kind of thing, to get a? You can't, because we don't have a line here. We have a parabola. Totally different scenario. It's just something I wanted to point out. Okay. Well, here's another example. Let's now find a quadratic function where this is true. The vertex is now the point 3, 5, and it passes through this point. Here's the vertex. It's passing through this point. Well, again, it's just like the other example, right? Here's the form we're going to use, and this makes it easier because we know the vertex, right? HK is the vertex, right? So HK must equal 3, 5. We're given that 3, 5 is the vertex. And if you have 2 points equal, their x coordinates are the same, and their y coordinates are the same. So altogether, since we know what h and k are, we know f of x must look like this. A times x minus 3 squared plus 5. But again, we're not done, right? We have to figure out what a is. But we know the graph, we know that the function passes through this point. So this point must be a solution to this equation, just like in the other example. In other words, f of -1 is -4. So when x is -1, f of x is -4. Okay? Okay, let's use that. Namely, we know this is f of x, right? That's what we got. So when x is -1, f of x must be -4. We plug it in, right? And now, we simplify the right-hand side a bit. We get -4 squared plus 5, which is a times 16 plus 5. Now we solve for a. A here is the unknown. Instead of a times 16, I wrote 16 times a, mostly because the unknown, the number is a coefficient here, 16, and a's are unknown. I mean, if you left it as a times 16 down here, I'm not going to take off points. So I just wanted to point out what I did. But just like before, we have to solve for a. We isolate a. So I subtract 5 from each side. Minus 9 is 16a. Then we divide, as you can see. And we get a, and we get negative 9 over 16 equals a. I mean, really, I should have kept a on the left-hand side, but that's okay. Either way, we see what a is, and we get this. So this is our function. Again, you could graph that in decimals if you want as a check. You don't have to, though, but you could. Also, fractions, you don't have to write them in lowest terms. In reduced form, you don't have to write it in lowest terms, that is, because I didn't review that. I know theoretically you're supposed to come into the class knowing how to write a fraction in lowest terms. Again, I didn't review that, so I'm not going to ask you to do that. Okay. Are there any questions on this? Okay. So let's do another one. First, let me stop the recording. So the next one is